physics step by step. We're going to have a look at the latent heat. We're going to look at specifically the latent heat of fusion, and we're going to have a look at the latent heat of vaporization. Fusion, when we change a solid into a liquid, and vaporization, when we change a liquid into a gas. So we're going to have a look at a couple of experiments trying to do this. Let's go and have a look at the setup that we've got and see how it's going to work. So what I've got set up here is I've got a power supply. The power supply is going into an immersion heater. The immersion heater comes out and will go to an ammeter and then back to the power supply. We've also got another couple of leads out here and across the immersion heater, which goes to a voltmeter, so I can read the current and the voltage. And what we'll also do is we'll set up a timer so we can record the time. We've got a balance, and the balance here is going to record the mass of the water we're going to produce. So the heater is going to heat up some ice, which I've got right over here, which we're going to sort out in a minute, and so we're going to record this. So let's start the experiment by recording what we need to know. So the first thing I need to know is the mass of this beaker, and once I know the mass of the beaker, then we can work out various other things. So let's set this up. I'm just going to zero my balance. Which is not very helpful. I think it's saying I'd like some electricity. How boring. What always happens is when we try and do some of these experiments, they don't always quite work as we expected. So if I just pass you the, there, it is working now. Typical. Right, it has zeroed. It says it's not quite right. I'm just going to switch it off. Things don't always work out in science as I want, especially when I'm trying to do these things live, and they don't always work. So let's plug that in to the mains, and let's try again. And our beaker comes in at 185.03. So I'm going to record the empty beaker at 185.03. So we'll see how we manage with our mass as we go along. Right, so I've got a beaker set up under this funnel, and this funnel's got an immersion heater loosely dangling in it, so hopefully it doesn't touch the sides. And what we want is some ice. Right, so I've previously got some ice out, and what we're going to do is I've got my ice here, as you see, and what we're going to do is we've got to try and crush this. I'm going to put my safety specs on, and let's see what we can do. should have crushed that severely, and yeah, we've got some nice crushed ice. So let's carefully put this in. So let's readjust everything. What I want to do is start putting the ice in. Just going to move that out of the way because I don't really want to put the ice in the beaker at the moment, especially when I'm getting a little bit sloppy there. And what you can't appreciate here is this is blooming cold. I feel I'm starting to get frostbite on my hands. But time is of the essence here. Right, I've got some ice. And we're ready to start. So let's turn the meters on, let's turn the electricity on, and we'll start the stop clock. Right, okay, so we've got the stop clock going. We've got now some figures that we can have a look at. I've got 11.74 volts, 11.75. We've got about 3.69 amps going through, and we'll see how this goes. I'm going to leave this now for a few minutes, and while that's going on, I'm just going to mop up a little bit of water that I've managed to throw everywhere. I am a little bit lethal, I suppose, with the ice. So let's just dump the extra ice over there. Right, okay, so the experiment is going. We are getting some water coming down. Of course, we will get some melting just due to the temperature of the place. I can't do much about that. But we will get some water coming through. How are we doing on our timer? 1 minute 47 so far. So let's record the voltage. So this is the empty beaker. What I am going to have is a full beaker, and so I can take the two numbers away from one another. I'm getting some sounds here. But hopefully that should allow the water to go down okay. I've managed to make sure that the element's not touching anything else. So we've got the amount of water we're going to calculate. We've got the voltage. And at the moment that's 11.78. We've got the current, and that is set at 3.7 amps. and the time which we're going to want in seconds when we've actually managed to achieve something. And we can run this for probably about 10 minutes to sort of work out what we're doing. So let's now leave that going for a few minutes and let's have a look at what we're doing. Put into this funnel, which we've put in fairly crushed ice in there, and hopefully as that heats up this will fall and still be in contact. It may or may not. Under this we've got our beaker, and this will gradually collect the water in here as this ice melts. So the ice melts and we collect the water. We can work out the number of joules of energy used, because this is going to be our work and it's going to be our voltage times our current times the time taken. We can work out our mass of water made simply by taking the final amount minus the initial amount, and that's going to equal our mass of water. So we're going to try and work out something called the latent heat of fusion, the specific latent heat of fusion, I suppose, if we want to be as accurate as we can, and that is going to be the energy that we have put in joules divided by the mass of the water that we've made. And I'm seeing this working quite nicely. I'm having to quickly come and rescue this a little bit. If my son will change the camera over for me. Have you done that? Yep. What I've got here is it's getting quite hot, and so I'm just trying to push some of the ice down. I have a feeling I was getting a little bit of steam produced. So we're at 8 minutes 30 seconds. That really isn't helping at the moment. I thought I'd try and hold it up. But what was happening was it was sort of blocking I'm not sure that enough ice is coming through. We're on 9 minutes 24, so we're nearly ready to stop. I feel I'm wasting some heat coming off of this, but it'll give us an idea. So we're on 9 minutes 41 seconds, coming up to the end. Still got a fair bit of water coming through. 59 and off. Right, okay. Now I'm going to leave this just dripping just for a few moments because the heat in this is going to allow some more water just to come out. There's residual heat in here, so I'm just going to allow it to run just for a few more moments. But I don't want to allow it to go much more than that. Yeah, and I think we'll leave that at that point. So let's just take this out. I'll put that down out of the way. And I'll take this out. Right, so let's have a look at the water and see what's happening here, and we'll do some calculations and see what's happening. So I've now got 247.75. So I've recorded that and we're off. Okay, so let's go back and do some calculations. Right, now while we're doing that, my son's going to get the next experiment ready. He's just going to put the kettle on and boil it and get that one ready so that we can cope. Right, so let's do this calculation. First of all then we need to see how much we've actually got. So let's do our calculation, and our calculation is simply 247.75, and we're going to take away from that our initial amount, which was 185.03, and that's going to give us 62.72. So our amount of water is 62.72 grams. We also measured the time, and the time we had was 10 minutes. What is 10 minutes? Well, that's going to be some 600 seconds. We've got our voltage, we've got our current, and we've got that. So we're going to multiply those together. So let's go ahead and do that one. So we've got 11.78. We're going to multiply that by my 3.7. and we're going to multiply that by 600 seconds so we know how many joules we used, and that's about 26,151. It did have the 0.6, we might as well put that in for fun. So we've also got our mass, which is our 62.72, and we're going to put that into this formula to work it out. So our specific latent heat is going to be 26151.6 divided by 62.72. I've got that number in the calculator. Let us divide that by, I could have stored this, 62.72, and that gives me 416. If I really want to be accurate here, we'll call it 417. And our units are joules per kilogram. So there is my calculation for determining what for this experiment was our specific latent heat of fusion, of turning ice into water. Now, how accurate was this? Well, not very is the answer. So it's what we did and how we managed to do it, and we managed to get something. What are the problems with this is really trying to get this ice to keep moving down and touching this heater. It is trying to make sure that the full length of the heater is used all the time rather than just at the beginning. So we're wasting quite a lot of heat, and we saw a little bit going wrong before I had to go and rescue it. So it wasn't sort of working quite as well as I would have liked it to do. But then that's experiments for you. Right, that is that done. Our next one is, could we work out the latent heat of vaporisation? Now, the latent heat of vaporisation is going to be done with a similar type of experiment, but it's going to be slightly different. So let's go and have a look and see what we could do with this one. So what I've got here is a very similar type of experiment. We've got the same setup here. We've got my immersion heater. It's going to go in there with some water. It's standing on a block of polystyrene, and it's insulated. We're going to put a known amount of water in here, and we're going to switch the element on, and we're trying to get the water to boil. So the water should be literally boiling now, and what we're going to do is we're going to put some boiling water in here. So I'm now going to turn this on, and what I want it to do is for it to boil the water. So let's move the kettle out the way. And I don't really want to start the experiment at this moment, because what I want to do is get this water boiling properly. So we're going to try and get this element boiling the water. I can see, you can't quite because I'm right over the top, I can see that it is actually starting to bubble, and we might see that we're getting this number coming down, but I want to make sure this is boiling properly before we actually start the experiment. So we're nearly there on the boiling, and it doesn't matter where I start because we know what the mass of this is. So it's not quite boiling yet. It's bubbling, but it's not really boiling. So let's again leave this for a moment, and we'll go and record the setup and see what we've got before we start this experiment. So it is cooking at the moment, but we'll start it properly when we're ready. Experiment is set up largely the same in that, if I hold the pencil around the right way, it helps. We're going to have our battery source. We're going to go to an ammeter. We're then going to go to our immersion heater. And we've got a voltmeter across the immersion heater. This is then in a beaker of water, and it's not covering all the elements. What we're going to do is we have put insulation around the sides and around the bottom, and this is then standing on my scales, my balance, and that's got my mass on there. So we're going to again record the voltage. We're then going to also record the current, number of amps. We're going to record the time. We're going to probably do this for about 5 minutes, and we want to have the mass at the start, and we're going to have the mass at the end. So this is going to give us our mass vaporized, and then we should be able to work it all out. So there's everything ready to go. The equipment should be now ready. So let's go over and have a look at this experiment, ready to start it. Well, it's just about boiling. I think that's probably as good as the boiling's going to get with this element. So let's start the recording. So I've got the timer down here, and I want to make sure that none of the leads moving. So this is 441. 441. Here we go. So mass at start 441, and that was about 0.2. I'd have to move the video back to try and record what that is going to be. And we're going to run this for about 5 minutes, and we're going to see what we're actually going to get there. As long as I don't touch anything, it's going to be okay. Our voltage is 11.76, so it moved to 11.77. okay, 11.77. My current is 3.67. My time will determine, but we're aiming for 5 minutes, and we can already see the mass has gone down. We're at 439.94, and it is steadily going down, so we are getting some water evaporated. It is bubbling steadily off of the element. I won't say that it's doing brilliantly. Probably not the best element in the world for trying to do this. But hopefully we will see some change. We can try and do this with a kettle. Unfortunately, most kettles these days, they try and put a switch in to switch them off. Otherwise they do work quite effectively. But the heater in them is a lot more powerful than what we've got here. So nearly halfway through the experiment, we're at 483. We started at 441, so it is going down gradually, trying to sort of make some progress, and I'm not that happy with that element really. It is bubbling. But it's not what I think of as a happy boiling when I've got something like a Bunsen burner going under it. That sort of seems to boil a lot better, so the element's not that effective. And I've only probably got 2/3 of the element in the water. So we're coming up now to 3.5 minutes, and getting on towards that, we're going to see we're down to 437. So 3.5 minutes coming up, and we are down to 437. So we've actually taken out about 4 grams of water so far. So this is not going to be a large number like the other one. We're looking at a fair amount of energy having to be put into a system to turn something from a liquid into a gas. It takes quite a lot of energy. So typically boiling some water, if I boil some water from room temperature up to boiling, it takes at least as much energy again to start turning this to a gas. So it does take quite a lot of energy. I'm noticing the ammeter's up at 3.7 at the moment instead of 3.6, and my voltmeter is down at 11.71. So I may go with that. We're at 4 minutes 46.7. So I'm nearly ready to stop this. And I'm going to leave this again another few seconds just to see that the heat already in the element is actually going to be used up. You'll see it's wavering around quite a lot, and this is due to the fact that I've got sort of this a little bit squiffy. But I don't think we're going to do much more. It seems to have stabilised round about there. So I think we're going to call this 435. What do you reckon? 435, here we go, going up. 43570. It's going to be as good, I think, as we're going to get. Let's go over and have a look at the results. So our time of 5 minutes is going to be 300 seconds. So let's work out our energy. Our energy is going to be, we're going to take those figures, 11.71 times 3.7 times 300. The mass we've got, let's calculate that. So our mass is going to be 441.2, and we're going to take away from that 435.7. So that's going to give me a simple mass of 5.5 grams, which is not very much. The energy put into this, I'm just going to store that in memory A. Let's cancel, is going to be this sum. So it's going to be 11.71 times 3.7 times my 300s for the time that we took. And that's going to give me this massive figure here of 12,998.1. So there's my energy. To work out what our specific latent heat of fusion is, sorry, this is vaporization, specific latent heat of vaporization, it's going to be this 12,998.1 divided by the mass, which is 5.5. And putting that into the calculator, we've got this number, and we're going to divide by memory recall A, and that's going to give us 2363.29. And again, this is measured in joules per gram. Now, with both of these experiments, I've actually done them in joules per gram. I wrote kilogram on that one, but I actually did joules per gram. What would be sensible is to turn both of these into joules per kilogram. And to do that, we're going to need to divide both sides by 1,000. So this is going to be 2.3. And this one divided by 1,000 is going to come out as 0.417 joules per kilogram. There's two experiments looking at the specific latent heat of fusion, specific latent heat of vaporization. My figures weren't particularly accurate, but that doesn't really matter. What matters is how we did the experiment. There are lots of faults with the experiment, how I've got them set up. The faults we've got, firstly, with the ice, is fairly simple, that the ice isn't in contact with the element. With the second experiment, really we've got a lot of this element not in contact with the water, so a lot of heat is going to waste. So these experiments need improvement, but they do give you an idea about how things work, and it gives us an idea about how the experiments are done and some ideas. So not as good as I would have liked, but they are what they are. If you found this useful and want to continue, then please subscribe. That helps me a lot. And what we also want to do is get you to come back and watch more on this. We are going to have a look next time at gas, pressure and temperature. We're going to worry about Mr. Boyle and Mr. Charles and their laws. And I'll see you then. Take care, stay safe. Bye bye.